Hey guys, Mr. Longbrake here. Today we are going to talk about acceleration. Number one, how to solve for it, but also what it is and how to determine if acceleration is occurring on a position time graph, motion diagram, or velocity time graph. So first of all, what is acceleration? Acceleration is a change in speed or velocity. So basically what that means, whenever you have motion that is changing, something is changing its speed, whether it's increasing or decreasing its speed, there is acceleration present. Now, positive acceleration is if something is increasing its speed or velocity, meaning it's speeding up. Versus negative acceleration is going to be when something is decreasing its speed, meaning it's slowing down. So whenever you have motion that is not constant speed or velocity, then you have acceleration. It's positive acceleration if it's increasing speed or speeding up, and it's negative acceleration if it's decreasing its speed or slowing down. So how do we solve for it? What is the formula? Acceleration is going to be equal to VF, which is final velocity, minus VI, which is initial velocity, in parentheses, all over time. And over here, I'll label what each of those variables mean. A is acceleration. That's what you need to be able to solve for. VF is final or ending velocity. VI is initial or starting velocity. And T is time. So time is going to be in seconds. VI is going to be initial velocity in meters per second. Same thing with final velocity. And acceleration's unit's going to be meters per second squared, a unit that we really haven't seen before. So let's do one practice problem, and you'll be expected to do 2 of these on your own in the Schoology assignment. So first thing I'm going to do is I'm going to label my givens. It says if a car started out traveling 10 meters per second, that is an initial velocity. That's what the car started out traveling, its initial speed or velocity. And then it sped up to 35 meters per second. That is its final velocity or ending velocity in 5 seconds. That's its time. And then it says, what is the car's acceleration? So we're looking for A, or acceleration. So now I'm going to go ahead and plug in those numbers to our formula up above. Acceleration, which is what we're looking for, is A, equals parentheses, and those parentheses are important. 35 minus initial velocity, 10, all over time, which is 5. So order of operations, I am going to do what is inside the parentheses first. So A is going to be equal to 35 minus 10 is 25, and then it's still divided by 5. So last thing to do is just divide those 2 numbers. A is going to be equal to 25 divided by 5 is 5. And so our answer is 5 meters per second squared. Now, the sign of that acceleration is really important. This is a positive 5. And that tells us that it is positive acceleration, meaning that the object sped up or is increasing its speed, which makes sense. It started off going 10 meters per second, and then it went 35 meters per second, showing that it increased its speed, therefore it should be positive acceleration. If an object decreases its speed or slows down, you should see a negative sign in front of your final answer, showing that it's negative acceleration. Now, the next important skill is to be able to understand whether acceleration is occurring on a position time graph, velocity time graph, or a motion diagram. And so first thing I want to talk about is zero acceleration, meaning acceleration is not occurring. And essentially what that means is constant speed. Because if you have an object that is not accelerating, that means its speed is not changing, therefore it is a constant speed. So on a position time graph, anything showing constant speed will show zero acceleration. So constant speed on a position time graph is shown by a straight diagonal line. So that would show zero acceleration. This would also show zero acceleration. Both are constant speeds, just one is in the positive direction, one is in the negative direction. On a velocity time graph, remember adding these numbers really helps. Any straight horizontal line will show zero acceleration. So here would be zero acceleration. This would also be zero acceleration. This is 3 meters per second constant speed over time in the positive direction because it's in the top quadrant. This is constant speed in the negative direction because it's in the bottom quadrant. And then lastly, how do we show it with a motion diagram? Well, constant speed is shown by the dots being evenly spaced. So all three of those would show zero acceleration or constant speed on those particular diagrams or graphs. Okay, next let's show positive acceleration. And essentially that means, remember, speeding up. If something is increasing its speed or speeding up, then it's accelerating, and it's positive acceleration. So to show something speeding up on a position time graph, we're going to have a slope get steeper. So this would be positive acceleration or speeding up on a position time graph because that slope is getting steeper. It's steeper at the end than what it was at the beginning. And this would also be increasing speed. It's steeper at the end than it was at the beginning. The only difference between those two is one of those is the positive direction going away from the origin. The other one is the negative direction going towards the origin. So please do not get confused by positive acceleration meaning that it needs to be in the positive direction. It does not. Positive acceleration just means speeding up, no matter which direction that object is going in. So both of those would be positive acceleration or speeding up. On a velocity time graph, remember adding these numbers really helps. We need to show something speeding up. That would be speeding up in the positive direction or increasing speed in the positive direction. This would be increasing speed. It's just in the negative direction because it's in that bottom quadrant. Both of those would show positive acceleration. And then lastly, a motion diagram to show something speeding up. The dots get further and further apart. The further apart the spacing, the faster that object is going. So all three of those would show increasing speed, speeding up, or positive acceleration. All right, lastly, we have negative acceleration. And negative acceleration just simply means slowing down. Or an object decreasing its speed. So if something's slowing down or decreasing its speed, we say it as negative acceleration. So on a position time graph, to show that, we need to show the slope getting less steep or shallower. So this would be decreasing speed or negative acceleration because the slope is less steep. Here, it is less steep or shallower than it was to start. Another way of showing negative acceleration on a position time graph would be a line like that. The slope at the end is less steep than the slope was at the beginning. The only difference between those is this is negative acceleration in the positive direction going away from the origin. This is negative acceleration in the negative direction going back towards the origin. On a velocity time graph, gonna add our numbers here again. Decreasing speed means I'm going to start at 3 meters per second and then start to slow down. That would be decreasing speed in the positive direction because it's in the top quadrant. This would be decreasing speed in the negative direction because it's in the bottom quadrant. Okay, and then negative acceleration or slowing down or decreasing speed with a motion diagram I'm going to show the dots getting closer and closer together, decreasing their spacing, meaning that that object is slowing down. So all three of those would show negative acceleration, slowing down, or decreasing speed. Okay guys, that's it for acceleration. As always, if you have any questions, please do not hesitate to reach out via Schoology, email, or check into our Google Hangout. All right, have a great day guys, and I miss you. Bye.